Hey everyone. So most functions get complicated really quickly, and one of the most frequent things you'll see is a composite function, which is where you have one function nested inside of another function. You might even have a third function in there, or a fourth or a fifth. They get nested inside each other, and it gets complicated in a hurry. Like cosine of x squared plus x, where the inside function is the x squared plus x. Like if you're following the order of operations and if you're pretending to be x, you're getting squared and added to yourself, and then after that you get cosigned. So the outside function is the cosine. In case you're wondering, this is what this graph looks like. It's kind of cool. So we're going to learn how to do the derivative of these composite functions. The best way to deal with these is actually verbally. So the way this works is you take the derivative of the outside function, and then this is important, while you keep the inside function the same, and then you multiply that by the derivative of the inside function. These are the steps. These words are going to be in your head repeatedly. So every single time you do this, this is what you'll be thinking. I mean, you could be thinking about it in terms of like f, and if you have f of g of x, which is how you've seen composite functions written before. But quite frankly, this is not user-friendly in terms of remembering it. The words are way better. So let's take a look at a few examples here. We actually saw this problem the other day, and our textbook told us to be clever. And the cleverness was for you to somehow magically come up with the chain rule. Not going to happen. So we have our friendly Kraken to help us out here. So I apologize in advance for all the pen clicking I'm going to do so I can move between the colors. So the derivative of the outside function. Our outside function is that third power because it's the last thing that gets done. So the derivative of the outside function is 3 blah 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 on the inside, new exponent of 2. And then while keeping the inside the same, so I have my 2x plus 5 on the inside. And then finally times the derivative of the inside function. So the derivative of our inside function, that being a linear function, derivatives are slope. Slope of that line, 2x plus 5 is a 2. So there we go. We actually can stop right here. Obviously, if this were a multiple choice question, you would have to be like, okay, don't be lazy. Y prime equals 6 times the 2x plus 5 squared. We don't need to go here. Stop here. It sounds kind of weird to say not simplify things, but the reason we're not going to simplify is that this is a question of calculus, not algebra at this moment, at least. Okay, let's do another example. The best way to get good at these is just to see a few examples. So looking at sine of x squared, because we know the derivative of sine is cosine. We just learned that one. So we have our outside function being sine, the inside function is x squared. So the derivative of the outside function, so cosine, is the derivative of sine, while keeping the inside the same, and then times derivative of the inside function. And again, we don't need to clean that up. Okay, another example here. And this is where it's going to get even weirder. So looking at sine squared x, which is how things get written, it's not clear what the inside versus outside is. This is one of those things you have to automatically know what's inside versus outside. When you see sine squared x like that, what it really means is that you have sine x is the inside function, and the outside function is the squared. So you really have to watch closely when you see something like sine of x squared versus sine squared x. Anytime you see sine with an exponent on it, I suggest rewriting it with parentheses because then it's very clear what your inside and outside is. So derivative of our outside is going to be 2 times, and then our new exponent is 1. And then we keep the inside the same, and then multiply this by the derivative of the inside function. This happens to be a trig identity, but you know what? I don't care, because remember, this is not about algebra or pre-calculus, this is about the calculus. Let's return to that example we saw at the very beginning with that graph. We have cosine of x squared plus x. So just to give variety, let's do dy dx here. Not that it matters that much. And then derivative of the outside, the derivative of cosine is negative sine. And then we keep our inside the same. Our friendly Kraken is reminding us. And then this is really, really big, and people mess it up all the time. When you're doing derivative of the inside, they're like, oh, the derivative of x squared plus x is 2x plus 1. And they write 2x plus 1. And then they're wrong. This is not true, because when you're doing multiply by the derivative of the inside function, you're not saying multiply by the first part of the derivative of the inside function. You're saying multiply by that entire inside function's derivative. So there's going to be a second video showing some more examples of these types of problems, but this is really what you need to know. If you feel comfortable, go ahead and try it. It gets a little bit weirder if you have a third function inside or a fourth function, and you will see that in the next video.